Okay, this is section 6.2, calc, the inverse of a function, page 433. So we're going to look at, this is kind of a unique section in here, but it does have its advantages. So we're going to look at an inverse of a function. That is the sole purpose of this section. So if we have the inverse, let's start with a function. Let's say that we have a function with 1, 4, 2, 5. I'm just using the example out of the book, and 3, 6. Okay? First of all, is this a function? Okay. This is a function. All right? This is also called a one-to-one function. A one-to-one function. A one-to-one function. Now, remember that a function, just to remind you, a function is a relation in which every x is paired with exactly one y. In other words, there's not one x going to two different y's, correct? Okay, but in a one-to-one function, every x has a different y. Every element in the range comes from exactly one element in the domain. Now, that's not always true of all functions, okay? If you remember right, in all functions, it is possible, I'm just going to do this off to the side, it is possible if we go like 2, 4, and we could go 2, 5. No, excuse me. We could go 3, 4. Sorry. Okay? This is still a function because we have two numbers going to 4. Okay? It's still a function. Okay? What we can't do is we can't go 2, 4 and 2, 5. Right? We can't have the same x going to 2. That's not a function. Correct? Now this is not a one-to-one function. This is not a one-to-one function, okay? So a one-to-one function, every x has to have a different y. Now, one of the things I want to show you is, if I have a parabola, correct? Okay, and I have 2 points like this parabola is a function, isn't it?
Yeah.
However, is it a one-to-one function? No, because this x and this x go to the same y. You understand that? So therefore, a one-to-one function can be checked by a horizontal line test. You remember that? So we test a function by a vertical line test, and if you can draw a vertical line such that it intersects 2 or more points of a graph, then it's not a function. But the horizontal line test says if you can draw a horizontal line such that it touches 2 or more points on a graph, then it's not a one-to-one function. Do you understand that? Okay. All right, so we're going to talk about some one-to-one functions here. Let's go back to our inverse. Here's f, right? An inverse is f prime. That's how we denote it. Now, in calculus, that's a derivative. So you got to be careful because some math concepts are the same. Now, the inverse of this is we switch them around. Okay? We switch them around. So the x becomes the y, and the y becomes the x. Okay? Do you get that?
Mm-hmm.
Now, let me show you on a graph. I'm going to put this graph up here real quick. I'm going to move this up a little bit so we can see the points. Okay, I'm going to show you on a graph how these points look and what they are. Okay? I'm going to do the first ones, F in one color, 1, 4, okay, 2, 5, and 3, 6, correct? I'm going the wrong way, aren't I? 2, 5 would be this way and this way, correct? All right. Now, if I do the next one, I'm going to go 4, 1, 5, 2, and 6, 3. Okay? You can see. Now, the interesting part is, and this is what I wanted to show you, is all inverse of graphs, okay, all inverses of graphs are reflected across the y equals x line. That's this line right here. See this line right here? Okay? When you have an inverse, it's reflected over this line. Okay? See how this is reflected? And this is the y equals x line. You need to know that. because when we do a line, then you need to be able to distinguish where that's at. Okay, and I'm going to do that right now. I'm going to give you a line. Okay, I'm going to show you a line. Let's say that we have this line, y equals 4x plus 2. Okay, now what I want to do is to graph this line, and I'm going to use different colors again. I'm going to keep that same on there. Can you remember the line is 4x plus 2, y equals 4x plus 2? Okay, so let's erase these points. Okay, y equals 4x plus 2, so we have up 2, correct? And then my slope is 4, correct? Okay, now you have 2 points that I've graphed. I'm just going to show you. That 2 point is, that is 0, 2, correct? And this point is 1 what? 1, 6, correct? Okay, so I'm going to graph this line. All right, it looks like this. Okay? Does everybody see that? Okay, now let me show you. The inverse then of this line would be, instead of 0, 2, we're going to go 2, 0, right? And then this was 1, 6, we're going to go 6, 1. 2, 3, 4, 5, 6, 1. Joey, did you see how I did that?
Yes.
Okay, so I got my 2 colors. They're pretty close together, so let me change colors. Okay, so take a look at this. Okay, see how that works? And they're reflected across this line. All right, any questions on that? Now, that was an easy way to graph it, right? But what if I don't want to graph it? I just want to know what the inverse is. Let's go back to this line. Okay, but okay, I want to know the inverse of this. All right, so this is what I do. If this is f of x, sometimes they'll put f of x in there. You replace it with y. So I'm going to write that down. We're going to replace f of x with y. Do I have to do that on this one? No, it's already done. And then the next thing I'm going to do is I'm going to switch. I'm giving you a pattern for finding the inverse. I'm going to switch x and y. What do I mean by that? I'm going to replace this with x and this with y. Are you following that, Joe? Mm-hmm. All right. And then I'm going to solve for y. All right, so I'm going to solve for y. Oh, I wish I would have kept those lines up there. I erased them. So I'm going to go x minus 2 equals 4y. And then I'm going to divide by 4, correct?
Yeah.
So I get y equals x minus 2 divided by 4. And you can write that, you can rewrite that as f prime of x, or that means inverse, right? Mm-hmm. And notice I didn't have an x up here, but you can have an x. And I can put 1/4 x minus 1/2. Look at that.
Mm-hmm.
Do you remember what that line looked like?
Yeah.
Okay, let me do it again, but this time we'll do it, we'll use the slope and everything. The y-intercept was a negative 1/2, and my slope was 1/4, correct? So it's up 1 over 4. You remember that looked like that, didn't it?
Yeah.
Yeah, looked like that right there. So yeah, so we can do it both ways. We can graph it just using the points and the inverse, or we can simply solve for this. Now, it's important to know that this is an easy one, right? There are harder ones that we can solve for, okay? Let's take a look at this. Let's say that we had a parabola, okay? We had a parabola. Let me look and see if I can find one real quick. Or I'll make one up. Say that again. Y equals x squared minus 2. This is a parabola. All right. Let's say that I want to find the inverse of this. Okay. So I replace, if this is f of x, I replace it with y, which is already done. I switch x and y, right?
Yeah.
And then I solve for y. So x plus 2 equals y squared. Here's the point that you need to be careful of. When I take the square root of both sides, this becomes y equals plus or minus the square root of x plus 2. Mm-hmm. It becomes plus or minus. Remember that? And I'm not sure how the book will handle that, because that might not be a one-to-one function, but if you have to find it, okay? This is number one. Let's take a look at this one. This is a hyperbola. Okay, let's say that we have g of x equals x minus 4 over x minus 2. Now you'll see we have two x's, one in the numerator, one in the denominator, correct?
Yeah.
So we do the same thing, remember the steps, we replace g of x with y, right?
Mm-hmm.
Okay, that way we have one. Now we're gonna switch, and when we switch, this becomes y minus 4 over y minus 2, okay? And here's where it gets a little bit weird. We're gonna multiply both sides by y minus 2. Okay? That's a 4, by the way. Okay? Are we good? Now we're gonna distribute the x through. Change all subtraction to addition. And I'm gonna put the y's on one side, Joe. See that? So I'm gonna put the xy minus y, this y here, and I'm gonna put the x's on the other side, 2x plus a negative 4. Is everybody with me? All right, any ideas what to do now?
Add 4 to something?
No.
You subtract x.
Remember, we're trying to solve for y, right? So I'm gonna factor out a y. Do you see that? Right?
Yeah.
And then I'm gonna divide by x minus 1. Oh, when the 2x went over, it became positive. I'm sorry, guys. When that 2x became positive, correct?
Yep.
Alright. So then I get y equals, or excuse me, I'm just gonna write over here, f inverse of x equals 2x plus a negative 4 all over x minus 1. I would like you to replace this with inverse so we know that you're done with the inverse, okay?
Yeah.
Any questions about that? Okay, would you turn to the exercises on page
I
440?
have a question.
Yep,
So on the very last part of it.
Yep.
No, yeah. So it's 2x plus 4 or minus 4. Couldn't you pull out a 2 and you have x? Never mind. Nope, never mind.
yeah, you
So
can't
like
cancel anything.
Yeah.
Otherwise I would've, but yeah, if you could pull out a 2 and cancel it, yes, that would be awesome, but you
Yeah.
can't do that. Okay, so on page 440, the first set of problems, for each of the following one-to-one functions, find the equation of the inverse, write the inverse using this notation, okay? And then the 19 through 22 for each, sketch the graph of the inverse. So the first thing you're gonna do is sketch the graph and then do its inverse. So you might have to use points for that, okay? Find points and then inverse the point. Because you do have two parabolas. So let's say that I was going to do this parabola, y equals x squared minus 2. Okay, should we do that one real quick? Okay, y equals x squared minus 2. If I'm gonna do that one, I'm gonna do a parabola. Do you remember? I find the vertex, y equals x squared minus 2. I find the vertex is a negative b over 2a, right? So b is 0, right? So it goes through here, correct?
Yep.
Okay, so it goes through here and it goes up, right? Correct?
Yeah.
1 over 1 up, but how do you get the,
It's negative 2, you start at negative 2.
thank you. Why do you start at negative 2?
Because it's minus 2.
Yeah, but I want my x is negative b, right?
Yeah.
Okay? Oh, this is just down, right? We can just transform this down, right? That's what he's saying, right?
Yeah.
Okay, and then 2 over up 4,
Yes.
like this?
Yep.
Can we do that?
Yeah.
Yeah. So it's just translated, so it looks like this. So instead of finding the equation, all you gotta do is look at these points, right? For example, take a look at this point is 0, negative 2, right?
Yeah.
So then we're gonna do a negative 2, 0, right?
Yep.
And then we go 1 up, you just turn it sideways, correct? 2 down and 4, right? So it looks like this. 2 up and 4. So it looks like this. See how to do that?
Yeah.
Okay. And that's what they want on those. Alright? So your assignment, if you'll put it up on the board, Josie or Maggie, one of you two, will be page 440, numbers 1 through 15, all. 1 through 15, and then 19 through 22, all. Okay?
Through 22?
19 through 22. Yep. Okay.